Okay. And then small. Okay, so our colleagues online, you are hearing us? If you are with us, just give any sign that you are here. Sign. Yeah, Shan, you raise your hand. Please either write or just unmute yourself and ask. Okay, good. Okay, so actually today lecture is, so you can say it's the introduction of last lecture. So the good thing that today we don't have code to write, but we have a lot of things to go through in order to understand the different type of machine learning. So today we are focusing on the different type of machine learning. Actually, last lecture we got like a very short introduction. Any one of you still remember what's the type that we got last lecture? Clustering is unsupervised, yes. Yeah. Anything else you get from the lecture or no? Okay. So actually today, like last lecture, we give this clustering because it's important. Because if you are working with data as data scientist in chemistry, in biology, in ecology, you will collect a set of data, and then this set of data you need to cluster them in order to see the pattern, to see the relation between the different cluster, to see to study things, right? And this is why we start with clustering, because this is a thing that is normally happen. So once you collect the data, you clean the data, you start to make some statistic around the data. You start to visualize the data with some figures, binary diagram and ternary diagram, and so on. And then the next step after that is to go to cluster the data. And now we are going from, if you link this flow to scientific work. Normally, scientific work start with introduction, which is just to define your problem, and then you go to something, a section in your thesis or section in your paper to say data presentation. And so far, what we did is just data presentation. We just present the data either by some statistic or some figures after cleaning the data. And from last lecture, actually, we go to the second section or the third section of any publication or any scientific work, which is the interpretation of the data. Okay, so we start the interpretation normally with this type of clustering the data. to see how many cluster you have in your data, how many group or type of data that you have. And then we start to discuss the relation between the different variables in the data. And by the end of that, you come with a conclusion. So the course is designed as a flow of a person who write thesis or write a PhD or write a publication, scientific publication. Well, so actually we got this previous lecture, which was unsupervised data. And this unsupervised machine learning mainly to cluster the data. And you saw it's very easy. It's just one line of code. You don't need to write anything. It's just one line of code. And then all the complication actually is done by someone else, the person who writes this run of code. Good. So actually, we have 4 types of machine learnings. 4 types of machine learning techniques. We have something called, this is just to link between this introduction and the previous introduction, previous lecture, because this is the last slide that we got in the last introduction. So actually, we end our last lecture by this slide that say we have 4 types of machine learning. We have supervised, unsupervised, semi-supervised, and reinforced machine learning. The clear example of the machine learning that we got last week is the unsupervised one. Okay. So this is just an introduction or general introduction for this machine learning things or feature of machine learning. So machine learning is a computing intensive and generally requires a large amount of training data. As you saw last week, for example, we can't do anything without data. So we will not be able to run this clustering model without data. And we have to say that the data that we are used last week is not the data that the model was trained with. Okay.
Repeat that.
Can repeat that. So actually, when you are going to Python, for example, if you are going to Python, so if you are going to Python, for example, like last week, what we did, we just write a line of code, right? And we upload our data. And then Python succeeded to use this line of code in order to cluster the data. But this line of code actually is already trained by another, right? So actually what we need normally, if you are a computer programmer, you are work from scratch, you are create your machine learning tool, you need big set of data. Yeah. So imagine that you have big set of data, and then using this big set of data, you start to train your code, your algorithm. Okay. This training actually is, as we explained last lecture, for example, in case of clustering. So what you need to do is to plot this data in X and Y. And then the first part of your code is to write a code to calculate the distance between these pairs in order to see how much in total we have the distance. And this is the elbow method. This is the total distance. And then you start to add 1 point somewhere or 2 points somewhere, calculate the distance to this point. Then we will get the total, and then increase the distance, increase the cluster or the core of the cluster, and so on. And then you start to draw this line, and then you can say, okay, my cluster is here. This is the elbow method, right? And then after that, we start to use this number in order to find or redefine the clusters here. And in order to do so, we just put 4 points somewhere in our diagram. And then we'll start to move this 4 point within our data by automatic way. And each move, we start to calculate the distance from our data point to the center. Okay, and the minimum summation for this distance is this is our distance. Okay, so actually there is someone did that for us, all of this process, and by the end he just bring us one code, one line, and he say, if you would like to repeat this method, just use this one. And what we did last week, we got the theoretical part. We didn't develop this code, but we just get the theoretical part behind it. And we used another set of data. And we applied this code. And then we get our clusters. Okay, and this is what I mean, that the data that we used last week is not the data that the model was trained, because there is someone else who gets some data and use it to train the model. Okay, and this process actually is very intensive, very intensive process. Even I just yesterday heard about a new, but I don't know if this is correct or not. We need to explore this. Like Google, they try to build their nuclear station in order to get energy for their machine learning training. You can imagine how much it's intensive of data. They can't rely anymore on the normal electricity that is coming by the government. So they need to create their energy in order to make it. It's involved repetition training to improve the learning and decision-making algorithm. So you can imagine if I am a person who create such algorithm, this one at the extreme left, and I don't know who will use it, right? Maybe Mushtaq will use it in the chemistry, maybe you will use it in biology or ecology, maybe someone will use it in mathematics, I don't know. So I need to run several type of data type, right? From different fields, random way, in order to cluster, test, and cluster, test, and cluster, in order to fix this model. Okay, because as we will see next lecture, I think, there is something that here, when you are visualize the data, we see it in X and Y. But imagine that your data is a table that include 20 parameters, 20 variables. Okay, which variable of them that we will put it in the X-axis and which one will put it in y-axis. So our data, this data is a table. So this is ID, for example, and this is variables, and this is 20 variables. Which one of them will go to X? Which one will go to? Yeah. If it's one, but it's not, normally not. The ID actually is the identification of a dot. So when you are going to this dot by your mouse, you will find this dot is ID numbers 1, number 2, or number 3, for example. So actually it's not part of the data. It's sort of metadata. We can say it's metadata.
Maybe those two take each other. It depends on the data.
Yeah, maybe there is two. And in this case, we need to know which two. Right? Maybe more than two. Right? Right. Actually, next lecture, we will go to something called the PCA, principal component analysis. So again, it's very complicated methods, graphical and mathematical. We'll explain it, but there is code to do it. Okay? But anyway, in order for any scientist to create such X, Y, Z, you need to see you need to make this PCA in order to choose your X axis and your Y axis. And within X axis, the PCA there, it's called PCA1, principal component 1. You will find a big equation with a lot of parameters. Okay? And in y-axis, the same, like long equation with a lot of parameters. So actually, in order to create your training model, you need to get these parameters. So actually, your training model, your machine learning model, is not just mathematical things and the plot data and make like this. There is some parameters behind it. So you need to do some calculation in order to get this parameter. So it's not an easy, it's not direct. But again, you as a researcher in ecology or in chemistry don't need to go in deep. Right? You need to just understand what's behind this. You know, there is some people who are working there, they get parameters, they try to make this diagram. I know how to cluster the things, like, okay, if I plot the data, we can draw this and the process is like this, but you don't need to do it. But at least to understand what is going on. And in order to get this parameter, we need to repeat the training. You need to get more data, repeat the training, get the parameter, and then get a new data, repeat the training, check the parameter, is it the same or different? And you start to increase this process several times, do it several times in order to check that your parameter is the same. More data get added. Machine learning training can be automated for learning new data pattern and adapted it algorithm. So as we will see later, there is a method that we can apply in order to make the machine learning that we did automatic update themselves. Machine learning can learn from labeled data, and this is the supervised learning, or unlabeled data, which is unsupervised learning. We will come later to explain in more detail what is the supervised and unsupervised. Machine learning algorithms involve unlabeled data or unsupervised learning are more complicated than those that with labeled data. Do you know why? Well, will give you example. For the last lecture example, in our data, did we say that this row of data or this input is cluster 1 or cluster 2 or cluster 3, or just we put the data to the machine and then they discover the pattern automatic? Any input? Actually, our data that we put to the machine last week was something like this. It was like 1,200 row. Okay, but we don't have any indication for this 1,200 to say this is cluster 1, this is cluster 2, this is cluster 3. So actually machine learning, they did it for us. But you can do something different. You can know, for example, I know this data is cluster 1, for example. So you can add one row, one column at the end of the data, and you can say this is cluster 1, this is 2, this is 4, this is 3, this is 2, this is 1. And this is what's called is labeled. So it's one column, just you add it to the data. Okay. And by this way, the machine learning will know, okay, this pattern is equal to cluster 2. This pattern is equal to cluster 4. This is the supervised machine. You are guiding the code in order to tell him, okay, this pattern is that. So this is much easier than just leave it without any label. Finally, machine learning algorithm can be used to make decisions in some areas. And this also will get it like explain it in more detail in some minutes. These are just some examples of the machine learning that we use each day. Like logistic regression can be used for predicting which party will win at the bullet. So now I think the majority of the big data companies in US, they are working on which party will win in the election. And machine learning can make it. There is algorithm called Navbase that can separate valid email from spam. There is another things like email filtering to classify emails into spam or not spam. So actually, when you are opening your email, you will find that if you open your email and you open the spam folder, you will find some emails there. How the Outlook or how your email agent decides that these emails is spam or not, it's trained behind that. Okay. So it's like a mechanism. Look at the text in the email, and if you find in the text word, like for example, give me money or send me money or information about credit card, this is spam. Just put it in spam.
It's maybe a little bit small-minded of me, but I just really struggle with wrapping my head around the part that you explained, that you get you train it on a different data set. Yes. Then it can handle different kinds of data. Yes. It's just it's so crazy that it can do that in my mind, like different kinds of data. How does it know?
Well, it's depend on the type of the machine learning that you are reducing. For example, in our example, we are dealing with cluster machine learning algorithm. This is the previous lecture. And when you are clustering data, you don't know exactly what's the type of data. So it should be trained on all different type of data. Okay, regardless you are working in chemistry, in ecology, in biology, in mathematics, they can work on. Okay, but there is some machine learning algorithms just is made for biology. And in this case, you can't input data from mathematics or in chemistry, for example, to test this machine learning. It will not work.
It's just so crazy to me that it does work. You know what I mean?
It's work.
And, I just can't understand.
It's work simply if you return back to the introduction of the previous lecture, we got this deep learning and a neural network, and we said that. So how this thing is working? It's deep learning behind it. So actually we write like a logarithm, and this algorithm is divided by networks like this. Again, and many of this, and then you start to put an input. This input is just one row. Okay, and then this input will start to go to these networks, and in each network they test one variable by one equation or something like this, and the result will go to next one, and so on. And by the end, you will get, okay, all of these variables give like high value here, low value here. So this can be cluster one. And all the rest of the variables give low value here, high value here, for example. So this is cluster two. Okay, without knowing from where this data is coming.
I can ask one more question.
Yeah.
Sorry. Just when I guess it really depends on the question, of course, you're asking. But in my mind, if I'm an ecologist, I'm working on a project, and I have the opportunity to pick between two models, one that has been trained on multiple different fields, and one that has been more focusing on only ecology. Is it a strength or a weakness to have been exposed to so many different types of data? Do you understand my question?
Yes, I understand your question, and I can't answer it because simply if you know that these two models are working for another scientist, another students in your field, this doesn't mean that these two models will work for you. Okay, and this is the process that you as a scientist you are doing. Like, I know we have three models, for example, that can be used here. Two of them are developed just for ecology and one just published, like, can be used in any type of data. Okay, I can use it, the three, and test my data to see, this model are work, fine. This work, fine, but not so correct. This one is completely out of the context. So I will use this one, the first one. And this is your rule as a scientist. Again, you as a scientist, you are not blending. You are going, you understand things. You start to read around the models. Not all the models have the same strengths. There is some models that have weakness, and then you see, okay, if this weakness will affect me or not. Okay, maybe you see that there is one model that is developed just for ecology, but when you read the weakness, it doesn't work with me. My data has this weakness, and this means that the model will give me just rubbish data, rubbish interpretation. So I will use the one that is more common. Okay, so you need to read more around what you are using.
Just find it very hard as a scientist to make sure that I don't involuntarily cherry pick.
Yes.
So I find it very hard to take these decisions.
No, it's not very hard. It's just experience.
Okay.
No, it's not very hard. It's just experience, because if you have 1 year for your master thesis, for example, you will have enough time to test things. And this is master thesis because you are testing. You don't need to come with a solution that will fix everything. You just learn how to practice science. This is a master thesis. Well, for example, face detection, like what is used now in everywhere in the world, it's just training. Like, you know, if you are going to China, because now this is a famous example, China can know, or the government can know that you pass this street now. And if you passed it in while the red traffic is red, or the light traffic is red or green, right? How they know that Lisa passed away now? Simply, they have this code that trained by all the faces of the people of China, right? Of course, you smile because you don't know that the same code is used here. We have here as well, but the government didn't mention it, didn't say it, right? So, medical diagnosis. So we have a lot of codes that can discover things better. I have a friend of mine who are working here at the not medicine school, but the pharmacology, and he developed like a natural language process machine learning tool that can read, or not can read, but you can insert the reports, the medical report of people, and the machine learning automatic tell you this guy, he has this type of problem, or he will have this type of in the future. And he is just starting his PhD, so it's the same age as you. And he's not mathematics. He's just person like you, no? He's not doing like mathematics science, like easy peasy. Weather prediction as well. So you can look at the data and then you can find pattern to predict the weather. This is just an example of the different things that is used by the machine learning. So learning is a process of converting experience to knowledge. So it's very simple as exactly what you are doing. So when you start to interpret data, you are look at the data, understand pattern, and get conclusion. So actually, this is the same what the machine learning is doing. You are look at the data, get experience, understand the pattern, and then get the conclusion, which is, for example, in our case, is clustering. So it's the same methods. Okay, here there is something missing because yeah, here broadly they classified into 3 categories: supervised, unsupervised, and semi-supervised. But there is one missing here, which is reinforcing. So reinforcing is the 4th one. I don't know why it's not existing here. Maybe I deleted it yesterday. Now it's here. Okay. So supervised. Now we are, all of us know what is the supervised. Supervised is that you have the data and you have column in the data, which includes the label. And then you train your model with this one. So you tell them, okay, this data that is existing in this class, if you find this pattern, which is this 5, 6 students together, this means most probably this is big data course. If you find another pattern, which is include 2 of these students plus other students, this means it will be sustainability course. If you find different type of students, this means you are in ecology course, for example. And then just you need give the data, give a photo for the computer or for the machine learning and say, okay, I can see this pattern, so this is big data course because I see the people there, and so on. Unsupervised learning, this is the best example that we did, the clustering that we did last week. So you give the data without any label. Then we have semi supervised. I think it's easy to interpret what the semi-supervised is. Right? Anyone can say what the semi-supervised is? Easy peasy. It's in between. So supervised, we have 1,000 pieces of data and we have 1,000 label. This is supervised. The unsupervised, we have 1,000 and none of them has labels. The semi-supervised, we have 1,000, 300 of them with label, 700 without label. Easy. So it's mixed between them, and there is reason behind mixing between them. Okay. And then we have reinforcement learning. And this is, for example, in order to remember what's the reinforced learning, you can just remember what Tesla is doing in their machine learning tools. Okay, so the car for the Tesla, when they started their automobile things like cars that move without any person inside it, how this car is doing. Right, it's very difficult to get data to train this machine learning because you need billions of data, different cases. You need to train the car in Baghdad, in Iraq. You need to train it with data from Norway. You need to train it from data from US, and people has different pattern, different way of driving. How you make this, right? Any idea?
His own things and then put them and then add it together.
Yeah, you mean I bring a car, for example, with a data set from the pattern in US, and then get the pattern that is in Egypt, for example, and the pattern in Norway, and collect everything together. But this will take hundreds of years, right? You need to each city, even in Norway here, the people drive in Oslo different than in Tromsø, right? Because there is more traffic light in Oslo than in Tromsø. So how we can do that? Just to remind this one, because easy, by try and error. Get the car, make it work on the environment, and the car will make action. They will make problems or will make something, and then the environment around the car, person, for example, or traffic light or something, will make a reflection for this action. And the car has a sensor in order to get this reflection. And then they will see, is this reflection correct or not correct? If it's correct, this means that the car can do this action again. Not correct, this means the car should not do this action again. And this is reinforced. So actually, it's a bit complicated because here you have data, and this data can be labeled, can be unlabeled, and you train your model. Here, the car or the tool that you are creating, they create the data automatic. So they make action and see the environment, how they are interact with this action. And based on that, they start to classify and train themselves. Okay, so this is the reinforced learning tool. So this is some text about supervised learning. We can read it, but I think it's easy peasy now. A majority of practical machine learning use supervised learning. So actually, this is a very famous machine learning things. In supervised learning, the system tries to learn from previous examples that are given. So actually you are give them a concrete example. On other hand, in unsupervised learning, the system attempts to find the pattern directly from the example given. You can see the difference between the supervised and unsupervised. Now this sentence actually gives you the clear difference. So in the supervised learning, the system or the machine learning mechanism that you are creating learn from previous examples that given. You are giving, okay, people, the 6 students plus these 3 people who are online, if you find them together, this is big data course. Done. So once the machine learning finds this group together, it's big data course. Okay, if you find this number of students, this is ecology course. If you find these students, this is chemistry course. Okay, so you learn the system from previous examples that you give, concrete example. In the unsupervised machine learning, you didn't tell them this is big data course. You say, people, this group of students, sometimes they are come together. Okay, and this group of students, they sometimes come together. And this group of students, sometimes they are come together. And then the machine learning is go and see the pattern. Who is coming here? Who is coming there? Who is coming there? Okay, I can see 3 patterns. These students are come together every Monday, for example, too early Monday. Okay, so we can classify this as one group. I don't know which group, but I know this is one group together. And then this group are come together in one group. And this group, they come together in a third group. So actually in the unsupervised, they can look at the pattern and try to get something useful from. Okay, but in this case, they didn't know that this group is big data because we didn't label the group. It's, yeah, this is a group together, they appear together, they seem to be in one class together, but I don't know which class because I don't have this information. Okay, so this is a big difference between the supervised and the unsupervised. For the supervised one, in order to visualize it in mathematic way, we are working with 2 parameters, X and Y. And don't mix with this one, it's different, X and Y. So in the supervised way, we use X, which is the pattern that we see in the class, and the Y is the label. When you see this pattern, our label is big data course. When we see this pattern, our label is ecology course. When we see this pattern, our label is chemistry course. So we have X and Y. Okay. In unsupervised, as we will see in a couple of slides, we have only X. We don't have Y. Okay. So Y will be created automatic by the machine learning. Okay. Any questions so far? No questions? Maybe you can just finish the supervised, take break, and then come back. So when an algorithm learns from example data and associate target response that can consist of numerical value or string label, such as classes, tags, in order to later predict the correct response when both with new sample come under the category of supervised learning. It's the same blah, blah, blah. Like, you know, the machine learning learn from data and label. This approach is indeed similar to human learning under the supervision of teacher. So if you look at, for example, home learning and learning in a class in here, normally at any class you have in university, when you are in class with teacher, the teacher sometimes challenge you with some questions, but by the end of this question, he supervises you, like he tell you, okay, but the answer of this question is like this. Okay, so the teacher, when you are in a setting where teacher is there, the teacher normally give you the information. By the end of the lecture, within the lecture, but they give you the information because this is their role. If you are studying the course at home, it's not easy to get the information from someone, but you try to understand from the text the pattern and get the information from this pattern. So this is another example from the supervised and unsupervised. This is just an example. Like, this is, you can say, for example, like this, and take an image. And then like this, and take an image. And you say, this is 1, this is 2, this is 3, this is 4. And you train the machine learning with several images. And then you give it the hand for someone who make like this. And it automatically would say, okay, I know this pattern, it's 1. Okay. Or for example, the email, read the email, find some word, and if you find this word, it will be spam. If you didn't find it, so it's not spam. It's again supervised machine learning. I think, yes, this is the last slide before the break. The different category of supervised machine learning is we have 2 big categories: classification and regression. Classification is simply, we need to classify again the email. We need to classify the email. Is it spam or not spam? This is supervised. This is a classification. Okay. The regression actually is a bit complicated, but again, it's the same. Like, you can train, for example, we can actually use this an example. The first one is regression, and the second one is classification. So the first one, you create value out of your machine learning. Like, if you raise your hand like this, okay, this means it. It's value. But when you are classifying the emails, you can classify it either to spam or not spam. So we have these 2 major type of supervised machine learning: regression or classification. Questions? No questions? Okay, have like maybe 5-10 minutes break. Okay, so we can come back at 9:15. And of you already start their master work? You started? Okay, what's the topic is?
The transfer of food from plastic to northern to Mars and how they
Okay, transform of plastics into food system,
into seabirds.
into seabirds. Okay. So what you are trying to do is to see the mechanism of how this plastic go to the seabirds,
Yeah.
or
And another guy, the name is not the thesis, this spring, he has analyzed the same birds for plastic, the amount of plastic in stomach.
Okay.
So I will look for.
And you try to find correlation, like to see if the high amount of plastic can affect on the behavior of the liver or blood amount. Okay. You can use this as well. Yeah. Because actually what you are doing, you can create supervised machine learning in this case, because you create this table without labels, like the physiological parameter from the birds, by testing liver and by testing blood. And then this guy who will defense this year or already defense, he creates the label, like, this bird has such amount of plastic. So you have both the data and the label, right? You don't have okay, good.
Yeah. I was thinking a lot. If you don't, do you need a break?
No.
Can I ask? The supervised and unsupervised learning. I was just thinking when the supervised learning has these labels, and if you have a data set, I'm just thinking. I always think it's the how to say it in English. Does it take a long time for supervised learning to get it right? Because maybe sometimes it's not completely exactly like the first example you gave it. Maybe it's like a slightly different. Like,
Yeah.
what if
Yes.
for the example with us 6 students? What if it's 5 students, so not 6?
Yeah.
Will it then? Yeah. Then will it not categorize? I know it's a part of learning, but like
that's good question. Yes. And if you return back to the first lecture in the course, we said that a lot of amount of data that you use to train a machine learning is much better than low amount of data. So if we say, I will give you the same example. I will give you the machine learning that we have 10 image for this class in different days, and it shows this 6 students. But also I give them like 4 images, 3 image for the same class with only 4 students, because there is 2 are missing. They was absent. And I give the machine learning the same class, like, this is a big data course. The machine learning will understand, if we have 6, these people, it's the same as 4, these people, as 5, these people. But if we train the model with low amount of data, only the photos that include 6, because we don't have enough data. Definitely, if you give him a photo with only 5 or 4, he will not interpret them. He will give error or will give wrong answer.
So is it wrong of me to state that supervised learning often needs very big data to get it right? And
No, not really. Both of them.
both of them need it, of course.
Yeah.
But okay. I'm just trying to make the difference in my head.
Both of them. Any machine learning need a lot of data. A lot of data. Either supervised or non-supervised. In supervised, there is error in all the processes. In the unsupervised one, you are giving to the code or to the machine learning data, and you tell him discover the pattern. Okay. So there is an error here that maybe he will mix the pattern. Makes sense. In the supervised one, you give them the pattern and you give them the label. So actually, the mistakes will be on you as a researcher, because you will give this label to the data by yourself. And maybe you as a researcher, you just make mistakes. Right?
So when you're building this, I have a concrete example. So I was, if you have time, I will keep it quick.
Nice.
So I was in a project, and then it was years ago. I didn't understand. I was just a part of it, and then I was told, yeah, we're going to use machine learning to make an algorithm because we're looking at the frequency of the gill lids opening and closing from videos, and then this was going to be correlated with like stress. So we have to see over time. So it was time and then the frequency of this gill. And then in my mind now, I'm thinking, so I understood by what they were saying. It's like, oh, it's very basic machine learning. It's not anything hard. So then if I was going to go ahead and try to do something like this, I was thinking maybe it would be good to have them supervised learning, because then I would start from the beginning and I know what I want. I want to look at the gill frequency and to look at this frequency. Then I know what I'm looking for. Maybe it's easier for me to label it instead of like having a lot of data and not knowing anything. Then I would use unsupervised.
Yeah.
Does it make sense?
Yeah, in this case, it's simple. If, for example, if you have low rate, this means it's not stress. If you have high rate, it will be stress. So it's easy to label it.
Yeah, because I could categorize, like if it's this many
Exactly.
within like so and so many seconds, then
Exactly. So you have only two cases, like, stress, not stress. And then you add your data, which will be like movie of video with a rate. And then you add this label, stress, not stress. Stress, not stress, and you train the model.
and then it's a supervised.
It's supervised.
Okay, this is what I was just thinking. Okay,
Yes,
then it makes sense.
Yeah. So again, it's depend on your story, what you would like to make. And you can see here exactly what you are saying. We have two major type of the supervised. The classification. What you are doing is classification. You was classifying this to stress or not stress. It's classification. So supervised is a good in this case.
Because that would not be regression.
No, not regression.
No.
Not regression. The regression, you can develop something in a scale from 1 to 10. For example, how much they are stressed.
Yes, but then it would be a regression.
This is regression.
Yeah.
Yes. Good. So we can start again. I don't think I need more time in the coming one, because the coming one is unsupervised. Now almost you understand what is the unsupervised one. So I will just read in order to make sure that you understand all the text. So unsupervised learning, the logarithms are left to themselves to discover interesting structure in the data. Okay, you didn't say this data is this things. You just leave the data and then they discover what is inside the data. Mathematically, unsupervised learning is when you only have input X. There is no Y. If you remember, in the unsupervised, we have X and Y. Here we have only X. This is called unsupervised learning because, unlike supervised learning above, there are no given correct answer and the machine itself finds the answer. Okay, so in the supervised, you have labels, which is correct answer. In your case, for example, the example that you give, when you have this rate, the animal is stressed. If you don't have this rate, it's unstressed. Okay, you can use the unsupervised learning. You can just remove this and you just discover the pattern. And then by the end, they will come with two patterns. I have two patterns, one with high rate, one with low rate. I discover these two patterns. It's up to you to say, this is class A, this is class B. Okay. Unsupervised learning is used to detect anomaly outer such as fraud, defect equipment, or the group customer with similar behavior. So, for example, if you have a market, like a supermarket, and you would like to study like Amazon, for example. Okay, so sometime Amazon is come to you with suggestion, and they say that, do you think you can buy these things? How they know that you will buy these things? Because they have machine learning algorithm that classify people who are buying from them, and they can see behavior. Okay, and based on your things that you buy from Amazon over time, they know you most probably lie within this category, and this means that you will need to buy something in the future. So this is unsupervised machine learning. Why it's unsupervised? Because there is no data say that Mushtaq, for example, is category A for Amazon, or Lisa is category B for Amazon, but they discover it from your pattern. Okay. When learning data contain only some indication without any description or label, it's up to the code or the algorithm to find the structure of the underlying data, to discover hidden pattern, or to determine how to describe the data. This kind of learning called unlabeled data. So it's the same, like, it's up to the code to find the pattern. We have two categories, the association and the clustering. So in the unsupervised, we have two major categories, which is classification and regression. Here we have association and clustering. And this is easy to remember. Okay, association is as the Amazon example, for example. Okay, how I know that Mushtaq, for example, his pattern put him in category A, because he buy from Amazon these things. Simply because there is machine learning, and I know when Mushtaq buy product A, product B, product C, most probably he will buy D and E as well, because he is within this association, within this category. Clustering, it's easy peasy again to remember. It's the same example that we ran last week. When we start to cluster data, we don't know exactly how many clusters we have, right? You just give the data to the code, and you ask him to classify or to cluster your data. So it's without any labeling. So association and association rule learn problem is where you want to discover rules that describe large portion of your data. For example, people that buy X will buy Y. And this association is used by this online things like Facebook and Amazon and Alibaba and all of these companies, they are using this one. Clustering problem is where you want to discover inherent grouping in the data, such as group customer by purchasing behavior. So if you look, it's almost the same. It's almost the same. Now we will go to this last one. It's not the very last, but there is one which is semi. This is the reinforced learning. And if you would like to remember this, remember it with the Tesla car, how the Tesla car is trained themselves. It's impossible to learn them with supervised data. It's impossible to learn them with unsupervised data. Correct? No way. You need years in order to train them. This. How they train it? They train it by the action of the environment. Like the machine that you are trained produce action, and then the environment start to interact with this action with something, and the machine start to spot the interaction, and based on that they start to classify the data and say this is good or bad. So reinforcement learning, a computer program will interact with dynamic environment, like the computer program for the car start to interact with the environment, with the street, for example, in which it must perform a practical goal. For example, play a game with an opponent or driving a car, for example. The program is provided feedback in terms of rewards and punishment as it's navigate its problem space. And then the machine learning will start to learn from this. If it's negative, this means I should not do this action again. If it's positive, this means, okay, I can do it. And so on. Using this algorithm, the machine is trained to make specific decision. It works this way. The machine is exposed to an environment where it's continuously train itself using trial and error methods. Okay, and actually it's a nice story because actually the first, the early machine learning algorithms, this is in very early 90, actually was working with this way. So this was one of the early machine learning algorithms that is people was using it. And it was like in chess game, like they start to train a computer to play this checkmate game. And the computer succeeded by, after some training, to win the game. So in this reinforced training, the learning data give feedback so that the system adjusts to dynamic condition. So actually the data is generated by the system. In order to achieve certain objective, the system evaluates its performance based on feedback response and react accordingly. The best known it's self-driving car, for example, self-car, and the cheese master algorithm, AlphaGo. So actually AlphaGo, this is the first algorithm to use this reinforce training. Good. So now we almost at the end of the lecture. Maybe we have still, yeah, we almost there. The semi-supervised. Now I think you understand what the semi-supervised. Maybe I can ask you again what the semi-supervised is. Yep, not all of them. Yes, but why? So the semi-supervised, as Lisa said, that it's just when if you have data and then you label just some of them, not all of them. Why you as a researcher, you can do something like this?
Supervised, then you will have some examples it can work from to try to look for this kind of patterns. Make sure it's more correct, maybe.
Yeah, this can be a reason. Yes, of course. Yes, completely agree. Yes. So actually you can use this in order to fix gap in your data. Yeah, yes.
First, maybe you can in the beginning the labeling, but then continues as the data grows. Then maybe you don't have to continue. If you have.
Yeah and no. Yeah and no, because now you are mixing between the training and the performance itself or the implementation. Yeah. Yeah, so actually what you are doing, you will train the model with data already we know, for example, the weather for the previous years, and then you ask the model in the future to create the label. So actually here it's not training anymore, it's the model is already start to work. So it's not really, you are mixed between this and that. But sometimes labeling data itself take time and take money. If you have 1 million piece of data, it take a lot of time. Okay, so for example, that the example that I gave to you last week, this 1,200 column, we spent almost 5 months just to clean up the data without labeling. We didn't make any label for the data. Just cleaning the data takes around 5 months. Okay, and then if you would like to label the data, this means that you already know the clusters, cluster 1, cluster 2, cluster 3, and then you start to fit your pattern with this cluster. And this can take maybe another 10 months. So it's cost money, it's cost time. So sometimes it's easy, okay, I don't have enough time, I don't have enough money and resources in my company. What I can do, I have 1,200 data set, I will label only 200 and make the machine label the 1,000. Okay, so it's again cost efficiency. So if some learning samples are labeled but some other are not labeled, then it's semi-supervised. It makes use of a large amount of unlabeled data for training and small amount of labeled data for testing. Okay. Semi-unsupervised learning is applied in cases where it's expensive to accurate fully labeled datasets. So if you have like an important project and you need to train your model, but you don't have enough resources, okay, maybe you just label 1/3 of your data and you start to work. For example, it's often requires skilled expert to label certain remote sensing data. For example, if we say the US Army, they will understand the behavior of the some country army, like to see if this army, for example, develop something. So what you are doing, you need data. In this case will be the satellite data. Okay. But if you make it like completely unsupervised, the machine will give you like clusters. They will tell you some clusters, and it will be so difficult in case of like image process in order to give cluster, because now you have geomorphology, you have land, you have people, you have behavior of people. You know, the cluster will be thousands of clusters, different thousands of options. So much better in this case is to go to the supervised learning. So if you find this type of shapes, this means this country has some military action, for example. Okay. But in order to train all the satellite data with such type of things, it's a huge amount of money, right? So what you are doing, you just give the machine learning some example. If you find this, if you find this, if you find that, this is just mean there is some military action here. And then you start to train your model.
That the software needs. And I guess it depends on the type of the code or the quality of the code, because then the less data it needs to train, the smaller initial training data set, the better for everyone.
No, actually, the more data is better. Yes, yes, but which type of data? And this is again what we explained in the first lecture, shit in, shit out. If you import the things with thousands of data points, okay, million of data points, but all of them is uncleaned, it's just rubbish, data that has zero value, data that has no value, data that is a string in numerical values or numerical in string, for example. What do you expect that will come out of this model? Just rubbish, rubbish in, rubbish out. So in this case, small data, clean data is much better than big data, but rubbish. But in order to produce a good model, you need big data. You can't train a model with only 2 photos, for example. You need 100,000 of photos. And as you start to increase the number of the data, the model start to give you much better results. Okay. And again, when I start to link, I would love all the time to link between the lectures because everything is connected. You said that the number of the category in the data. I think you missed what you are saying, but you said this sentence, the number of the category in the data will be based on how much data I put. You didn't say that, but I heard this. Anyway, okay. But how the model understands that we have 3 clusters, 4 clusters, 5 clusters in your data? How the model understands that in 1 million point we have only 2 clusters, 3 clusters? Anyone can answer this? The elbow method, yes. Okay. Now understand the connection. So here an incomplete training signal is given. So we're still in the semi supervised. So actually in semi supervised, we give incomplete training signal is given. A training set with some, often many, some maybe, some mean 1/3 of the data, maybe 1/2 of the data, maybe 2/3 of the data of the target output missing. This is a special case of the principle known as a transduction, where the entire set of problem instance is known at learning time, except for a part of the target. Okay, so you don't need to go for blah, blah, blah. 1,000 data, some of them are labeled, the rest is unlabeled. Why? Because of several reasons. It can be very cost to train all the data, okay? Or we actually need to fix a problem in the data. But here we are target not to train the machine learning to produce something, but to fix something, okay? Or with different objective, like, you know, you can to go for here for this type of machine learning if you have other objective in your mind. So we go so far for a machine learning type, supervised, unsupervised, reinforced, and the semi-supervised, right? And for each, we have a target. And based on that, you start to think about what you will do. Okay, for example, in your case, in your master, if you would like to develop something, the best thing will be the supervised. In the case here, simply because you will produce in your master the data, but your friend or the other master students create the label. So you have the data and you have the label. So we can go for the supervised. Maybe in another case, I don't have label. I need to classify my data, okay, or categorize it. So I will go to the unsupervised. If you are work in engineering, for example, and you need to learn from the process that you are doing, you will go for the reinforce, for example, and so on. Okay. We can classify the machine learning into different categories. So now we have this 4 main categories: supervised, unsupervised, semi-supervised, and reinforced. But we can classify them based on the process itself. So we have classification, machine learning that do classification, machine learning that do regression, machine learning that do clustering. So normally, classification and regression, this is supervised. Clustering is unsupervised. Okay. And here, for example, there is some things like classification. The easy way to understand the classification is spam and not spam. So if you find, if analyze your text, if you find these words, it's spam. If you find this no word, it's not spam, and so on. It's classification. So it's supervised training. Regression, like, you get a value out of your machine learning. This one is larger than this. This one is smaller than this, for example. Clustering, just as the example that we did last week. You have data, you need to cluster them, and this should be unsupervised. Because if you train it with supervised data, there is no need to make the machine learning because you already trained them, so you know the clusters. What's the point to run the machine learning? Okay. Then I think we almost finish. So this is the last slide. And this is the different library that you can use to do machine learning. If you look at the library, actually, NumPy, we already use it 100 times before. Panda, easy peasy, we use it. I can say that I speak with like 7 people who are experts in Panda. Matplotlib, again. So actually, none of these things is machine learning. It just, NumPy is a statistic package. Panda is just something to deal with data. Matplotlib is something to plot figures. Seaborn, which is the last one, is again something to visualize data. And the only here package that you need is scikit-learn. This is the data where you will find things related to machine learning inside it. And if you look at the code of the previous lecture, this code was the first code that the scikit-learn package appear. Good. So the good thing in this lecture, we don't have codes to run, which is good. The bad thing, it has a lot of theoretical background, but it's important to understand the difference between things. So actually, this should be like the introduction for previous lecture, but I prefer to make the introduction after you have to test it by yourself, to see how this cluster is working, how the machine learning is working, and then go to introduction. Great. Question so far?
The example Marte got with the master thesis. So then it was another student that has collected the amount of microplastic found in the seabirds, and then she is taking blood samples and liver samples to look at correlation. So we have two different data sets in a way, and one you said that this can be labeled. The first one, which how much plastic is in the birds. So if you label this, how can you, just as a practical example, and then you said then you have supervised machine learning.
Yes.
Can you explain to me how you can feed them her other data set that contains these other values? This needs to be labeled as well, doesn't it?
Yes, of course.
So
yes.
So they both need to be labeled.
No. No. So actually, maybe I can repeat the question just for the online people.
Of course.
Yeah. So Lisa asked now, because we give an example that someone would like to train or work with a data that is produced last year. And in last year, the guy who was working in his master, he or she produced measure the amount of plastics in some birds. And this year, we will measure like physiological parameters that are related to the same animals. It should be the same animals, yes, or the same birds. And then I suggested during the lecture that can be supervised data, because now we have two tables. One table that created last year, that the amount of the plastic, and one table that will be created by you this year. And then this is matching. So Lisa asked me, does we need to label both of them, like the table of last year and the table of this year, right? This is a question. Yes, how to link them. Exactly. Yes, it's very easy, because if you look at this table, you have the ID of the birds. So it's by bird, like, this is bird one. I know this is the amount of plastic that has come from this bird, and I know this is a physiological parameter, so I can link them together. Easy. So actually, we link them, or we label them based on the ID. But again, ID is not something that we train the data with, because it's misleading. So normally when we are trained the data, we should remove the ID. Sorry? It's the same bird. No. No, it's the same bird, because if it's different, it will lead to catastrophe. Yeah. Yes. Any other questions? So far, do you think the course is okay or makes sense? Stop. Good. Super. Well, maybe I can have a look, because actually unfortunately, the PhD students are not here. I didn't see Victoria, because I have a big issue on the 12th of November. We have a lecture on the 12th of November, right? And in this lecture, I will be away. So we need to find another time for this. And it's better to have this before the 12th of November. No, only this day. I will not be away. I will be in the Fram Center to present your results. Sorry? How many lectures left? This is a good question. Actually, we still have we are very flexible. We have a lot of lecture actually, but I can't tell you how many roughly. So this is the lecture of today, and then we have still multi-factor analysis. Actually, the principal component is next lecture. And then we will go to the lecture that how we collect the data. If you remember, we are just jumped into data analysis, and we missed the first lecture, which how we collect the data, right? So this will be lecture 10. And then we will go for natural language process, lecture for geology group. And then Spark and Hadoop, which will be like a very short introduction. What's lecture for geology group? It's a geology group, okay. And midterm exam, we already make it. I think we still have like 4 lecture more. How many weeks we still have? 1, 2, 3, 4. 4, yes. But I need to check, because maybe some lecture actually include two lectures. So this is one lecture. This is one lecture. Hadoop. Strange. The ethics of the AI as well. 5 lectures actually. Strange. Where is the lecture? There is no PowerPoint. Yeah. So actually we have 5 lectures left. Because if you remember, our courses start with the data management plan and end with the ethics of the AI. Yeah. So I don't know how many weeks we still have until the end of the course. So we have normally 1 week in October, right? 2 weeks in October? 1 week in October? Yes. So we have 1 week in October and 4 weeks in November, right? And then the exam, the oral exam, I think it's already set up into 5th of December.
It says on the schedule.
Yeah,
It says yeah.
5th.
It says 10th and 16th. So
10 and 16.
maybe I'm seeing wrong.
I think 5th and 15. I don't know if the administration put it in my calendar or not actually, but I think if I remember correctly, 5th and 15. No,
It says 10th for the written and the oral is 16th. It says on the calendar.
really? Okay. So do you think we can still have 1 lecture at the first week of December? Because here I can see there is no lecture, but we have a seminar actually. Actually, it's much better for us if we can get this lecture sometime early, just to give you space to study. It's not good to give you a lecture here and the exam will be after 2 days, right? Just to give you space.
That lecture the Monday, so the day before.
This is a good question. For me, no. We have a meeting with the rector in around 2 o'clock. But otherwise, I am free Monday. Are you all free Monday or all the day? No, 11. Next Monday. Which Monday, Lynn? Monday, next Monday, 11. No, sorry, 11 of November. 11 of November. Are you free, Lynn? I am not available, okay. Okay, but normally you think that Monday is more suitable for you. Not this Monday in general. No, I mean, for example, Monday is the 4th of November.
It's okay.
Not too morning, like, no. 10, 11. Yeah. Too early is not good. Okay, so do you think we can send like a doodle for all of the people because it's lecture, not seminar? So we need to include the PhD students who are not here. So since you like Monday, I can send a doodle. What's this? Okay. I can send a doodle with like several Mondays, and then you can choose, okay, I like this one. And then within this Monday, we can send either another doodle with time or with hours. Make sense for our colleagues online? Great, super. So it will be much better just in order to have the PhD student as well with us. Good. Great, super. We have only in the calendar 4 lectures, right? 4 left. Okay. This is simply because we missed a lecture before. Yeah, we have 1 lecture that is missing. This is why we are 1 lecture behind the schedule. This means either we will need to delete or skip 1 lecture or get 2 extra lectures somewhere. Because what we are doing now, you know, we have a lecture on the 12th of November. Okay, we will not get this one, but we will move it. Most probably we'll move it to 11th of November or another Monday or so. Okay, so we still need 1 lecture for the one that we missed already. To lecture in Monday. One day?
Different days. I can take it in one day, but I think
Well, actually, if we will go for 2 lecture in one day, we can do it in a better way. In this case, we can have the last lecture, the ESIC one, as a second lecture in this day. Because actually the ESIC lecture is not a lecture, it's you will teach me the ESICs. So it's like not teaching, but it's like more discussion. Yeah, more discussion, and this is why there is no lecture. It's more discussion, like, you know, once we finish our lecture, 1 hour and a half, for example, we can sit together for 1 hour more, 45 minutes more, and then we can discuss what you see from point of view that important to include in the ethics of when you are do with AI. Make sense?
yes.
Okay, so I will send the doodle, try to fix this lecture that we need to move. Okay, and then we will think about the last lecture, because normally we take this last lecture as social event, just to say hello for everyone, good luck with the exam. But if we didn't make it on the time, we can just bring it together with one of the lecture, like extend it with 1 hour or so. Okay, good. Great. So good luck with the homework. I don't forget to submit it on the 25th. Okay, and see you. I will not be here actually. Thanks a lot, Lynn. Bye-bye. Actually, I will not be here Thursday, but you know, Victoria will be with you. And please don't forget to download the QGIS. And maybe you can just play with it, like try to open database and see what is going there. Just to be familiar a bit. No, it's Thursday. No, sorry, Lynn. I am looking at a wrong agenda. It's Friday, yes. It's a Friday from 12 to 2 o'clock. Yep. Good. Oh.